There is a place between England and Denmark where on calm days fishing trawlers still drag their nets across a shallow seabed and pull up things that should not be there. Bones of elk and aurochs, antler harpoons with sawtooth barbs, fragments of human skulls, worked flint, lumps of compressed peat containing preserved seeds and birch bark. These objects surface from a depth of 20 to 30 meters, tangled in the same nets meant for cod and herring, and they arrive as quiet dispatches from a world that has not existed for nearly 8,000 years. They come from a landscape that was, for millennia, one of the most resource-rich and densely inhabited territories in all of northwest Europe, a place that today carries no name on any modern map because every last acre of it rests beneath the North Sea. The idea that entire civilizations now sit beneath ocean water is on its surface dramatic. It conjures images of Atlantis, of catastrophe, of legends swallowed by the deep. But the reality, as it usually does, proves more instructive than the myth. What lies beneath the sea in dozens of locations around the world is not the wreckage of some singular mythological kingdom. It is the accumulated evidence of a very specific, very measurable geological process, the post-glacial rise of the world's oceans, and the human settlements it slowly, sometimes suddenly, erased. The story of submerged coastlines is not a story of mystery. It is a story of climate, time, and the simple fact that for most of human history, the sea was not where it is now. At the peak of the last glacial maximum, roughly 20,000 years ago, enormous volumes of the Earth's water were locked in continental ice sheets that stretched across much of North America, Northern Europe, and parts of Asia. The consequence was straightforward. Global sea levels were approximately 120 meters lower than they are today. Coastlines extended far beyond their present positions. Entire continental shelves, now underwater, were dry land. Between Britain and mainland Europe, a vast lowland plain stretched unbroken, threaded by rivers, dotted with lakes, thick with marshland and temperate forest. Between Siberia and Alaska, the Bering Land Bridge connected two continents. In Southeast Asia, the Sunda Shelf connected the islands of Indonesia, Borneo, and the Philippines to the mainland in a single enormous landmass. Off the coast of Australia, the Sahul Shelf pushed the shoreline dozens of kilometers farther into what is now open ocean. These were not marginal places. Coastal plains, river estuaries, and low-lying wetlands are among the most productive ecological zones on Earth. They concentrate freshwater, plant life, fish, migratory birds, and large mammals in overlapping abundance.
This one is
for early human populations, foragers, hunters, fishers, such environments were not obstacles to be crossed. They were destinations. And as the ice began to retreat around 20,000 years ago, these landscapes did not vanish overnight. They were slowly, incrementally consumed by rising water over thousands of years at a rate that varied from region to region. In some periods, the sea rose at roughly 1 meter per century. In others, it surged faster, and the people who lived on these lands had no concept of what was happening at a geological scale. They simply noticed, generation after generation, that the water was closer than it used to be. Nowhere is this process better documented than in Doggerland, the submerged territory beneath the southern North Sea. The name itself is recent, coined in 1998 by the British archaeologist Bryony Coles in a seminal paper that reframed the region not as a land bridge, which was the prevailing description, but as a place of habitation. Before Coles, the archaeological establishment largely dismissed the area between Britain and Europe as a thoroughfare, a route that Mesolithic people crossed to reach places of greater interest on either side. Coles argued that this was a failure of imagination. The artifacts hauled from the seabed, bone harpoons, worked flint, animal remains, were not the discarded belongings of travelers. They were the material culture of people who lived there. The evidence has only grown since. Victorian-era oyster dredgers and trawler crews were the first to encounter anomalies. Bones of wolves, bears, woolly mammoths, and woolly rhinoceroses surfacing in their nets. Most were thrown back. Some ended up in private collections and small museums. In 1931, a trawler skipper splitting a lump of peat that had clogged his net discovered a 22-centimeter spearhead crafted from red, deer antler, notched with barbs and inscribed with parallel lines. It was later dated to 13,000 years ago, the first human artifact from the North Sea to be formally studied. Since then, beachcombers and amateur collectors have amassed an astonishing inventory from the intertidal zones, arrowheads, axes, hammers, adzes, and nearly 2,000 barbed points made from bone or antler. Fragments of human femurs and jaws have washed ashore. One find was a spearhead carved from human bone. But chance finds, however numerous, lack archaeological context, and they tell you that people were there. They do not tell you how those people lived, how they organized themselves, or what their world looked like. That question, what was Doggerland actually like, drove the landscape archaeologist Vincent Gaffney to begin, in the early 2000s, a project that would eventually become one of the most ambitious efforts in the history of underwater archaeology. Gaffney's insight was deceptively simple. The oil and gas industry had spent decades conducting three-dimensional seismic surveys of the North Sea floor, generating enormous datasets that mapped the geology of the seabed in extraordinary detail. Those surveys were designed to locate fossil fuel deposits, but the same data, Gaffney realized, could be repurposed to reconstruct the topography of a landscape that had been buried for millennia. Working first at the University of Birmingham and later at the University of Bradford, Gaffney secured access to thousands of square kilometers of seismic data from the petroleum company PGS. The initial dataset covered 6,000 square kilometers, a staggering area by archaeological standards. He processed it through high-powered computers, projected the results onto a stereoscopic screen, and watched as the contours of an ancient world materialized. Valleys appeared, river systems emerged, estuaries, salt marshes, chalk outcrops and rolling hills became visible for the first time in 8,000 years. The land beneath the North Sea was not featureless sediment. It was a complete and complex landscape, one that had supported an entire ecosystem. What Gaffney and his collaborators have reconstructed over 2 decades of work is a picture of Doggerland as a northern temperate forest biome, a mosaic of deciduous woodland, grassland, marshland, and braided river systems. Evolutionary geneticist Robin Allaby, working with sediment cores extracted from the seabed, has sequenced ancient environmental DNA that identifies 574 distinct plant taxa. The Southern River, a waterway that once flowed through what is now open ocean 30 kilometers off the English coast, was flanked by willows, alders, elms, hazels, and oaks. Its estuary was thick with seagrass and marsh. The surrounding landscape teemed with the kind of biodiversity that would have made it, in Allaby's words, a very inhabitable landscape. For Mesolithic foragers, it would have been close to ideal, a place where fish, game, edible plants, fresh water, and raw materials for tool-making converged in abundance. The people of Doggerland were hunter-gatherers who lived in small bands, crafted tools from stone and bone, built simple shelters, caught fish with barbed harpoons, foraged for hazelnuts and berries, hunted deer and boar, and migrated with the seasons. This much can be inferred from the material culture of contemporary Mesolithic communities along the North Sea coast, sites in Britain, Scandinavia, and the Low Countries that represent the outer fringes of what was once a much larger inhabited world. In 2019, Gaffney's team achieved a breakthrough, the first directly prospected artifact from the North Sea seabed. A mechanical grapple lowered 30 meters to the floor of the Southern River site brought up a fragment of worked
depth of 20
flint,
meters, steady on the
the
winch.
edge of a hammerstone
25
used
meters, almost at
to
target
manufacture other tools. It was found near a chalk cliff, suggesting that the site may have functioned as a kind of stone tool workshop. For the first time, a human artifact had not washed ashore by accident. It had been found in place, in context, through deliberate archaeological investigation of the submerged landscape. Doggerland's disappearance was not a single event. It was a process that unfolded over roughly 14,000 years as warming temperatures caused ice sheets to retreat and meltwater poured into the world's oceans. The inundation was gradual, almost imperceptible on a human timescale, a matter of meters per century. Salt water crept up freshwater rivers, marshes expanded, Low-lying areas became tidal flats, then shallow sea. The landmass shrank, fragmenting first into an archipelago, then a single island, and finally a shallow sandbank, the Dogger Bank, which still rises from the North Sea floor midway between England and Denmark. By roughly 6,000 years ago, even this last remnant was gone. But there was, within this slow decline, at least one catastrophic punctuation. Around 8,200 years ago, a massive underwater landslide off the coast of Norway, known as the Storegga Slide, sent an estimated 3,500 cubic kilometers of sediment cascading down the continental shelf. The collapse triggered a tsunami of extraordinary scale. Waves struck the coastlines of Norway, Scotland, and the Shetland Islands, leaving sediment deposits that have been measured at locations far inland. The impact on Doggerland, already reduced and low-lying, would have been devastating. Research from the University of Oxford and others has modelled the Storegga tsunami's inundation of the remaining Doggerland territory, concluding that it likely flooded large portions of an already fragile landscape in a single event. Whether this was the final blow or merely one of many accelerating crises remains a subject of scholarly debate, but the convergence of gradual sea level rise and sudden catastrophe paints a picture of a world being lost on two timescales at once. Doggerland is the best studied example of this phenomenon, but it is far from the only one. Off the southern coast of Greece, near the tip of the Peloponnese, lies Pavlopetri, widely regarded as the oldest submerged planned city in the world. First identified in 1967 and systematically surveyed in the 2000s by a team from the University of Nottingham, Pavlopetri dates to the Bronze Age, with occupations spanning from roughly 2,800 to 1200 BCE. Its remains include streets, buildings, courtyards, and tombs, all resting in shallow water just 3 to 4 meters deep, approximately 20 meters from shore. Unlike Doggerland, Pavlopetri was not consumed by post-glacial sea rise. Its submersion is attributed to tectonic activity, a series of earthquakes around 1000 BCE that lowered the land below sea level. The city never re-emerged, and because it was neither built over nor disturbed by agriculture, its layout has been preserved with remarkable fidelity for 3,000 years. Farther east, in Abukir Bay off the Egyptian coast, the city of Thonis Heraklion lay entirely unknown until the year 2000, when the French underwater archaeologist Franck Godiot located its ruins beneath 6 meters of water, 7 kilometers from the present shoreline. For centuries, Thonis Heraklion had been Egypt's largest Mediterranean port, a gateway for trade between the ancient Greek world and the Nile Valley. Ancient texts referenced it. Herodotus mentioned it. But by the 2nd century BCE, the city had sunk beneath the waves, the victim of soil liquefaction likely triggered by severe flooding and seismic activity. Divers have since recovered colossal statues, gold jewelry, inscribed steles, dozens of shipwrecks, and the remains of temples dedicated to Amun and Aphrodite. The site remains one of the most significant underwater archaeological discoveries of the 21st century. Off the coast of Israel near Haifa, a Neolithic settlement called Atlit Yam sits 8 to 12 meters below the Mediterranean surface, roughly 400 meters from shore. Discovered in 1984 by marine archaeologist Ehud Galili, the site dates to between 6,900 and 6,300 BCE, making it one of the oldest submerged settlements ever found. Its remains include stone walls, a semicircle of megaliths, human burials, including the skeletons of a woman and child bearing the earliest known evidence of tuberculosis, and a freshwater well. The settlement was inundated by post-glacial sea level rise around 7000 BCE and has been preserved beneath marine sediment ever since. Each of these sites tells a version of the same fundamental story. The coastline where people once lived is not where it is now, and it has not been for a very long time. The question this raises is not whether underwater civilizations exist. They demonstrably do, but what their existence implies about how we understand the human past. The archaeological record, as it is conventionally studied, is overwhelmingly a record of what survived on dry land. But for most of human history, coastal zones were where populations concentrated. The shelves now submerged beneath the world's oceans represent cumulatively an area roughly equivalent to the continent of North America. If even a fraction of that territory was inhabited, and the evidence strongly suggests it was, then a significant portion of the human story is simply missing. Not destroyed necessarily, but inaccessible, buried under water and sediment beyond the reach of traditional excavation. This is beginning to change. The technologies that Gaffney pioneered in the North Sea, seismic reinterpretation, sediment core analysis, environmental DNA sequencing, AI-assisted data processing, marine magnetometry, are being adopted by researchers studying submerged landscapes in the Baltic Sea, in Southeast Asia, and off the coast of Australia. In 2025, NOAA-funded researchers began deploying artificial intelligence to detect submerged archaeological sites remotely, using sonar data to identify geometric anomalies on the seabed that might indicate human construction. The field of underwater landscape archaeology, once considered a niche curiosity, is becoming a discipline in its own right.
Colleagues, this map illustrates the scope of our discipline.
Unlimited.
From the North Sea to the Sunda Shelf, we see a global pattern of submerged sites,
is now
its own
being
conferences and a
claimed
growing
by
body
new
of
industries.
evidence.
Offshore wind farm construction across the North Sea, the Baltic, and elsewhere involves driving pilings deep into the seafloor, laying thousands of kilometers of undersea cables, and establishing safety exclusion zones that can make archaeological access impossible. Gaffney has described his work as a race, not against the sea this time, but against the infrastructure being built on top of it. Each wind turbine foundation displaces sediment that may contain irreplaceable evidence. Each exclusion zone forecloses an area that might otherwise yield artifacts. The irony is layered. The fossil fuel industry, whose seismic data revealed Doggerland, contributed to the climate change now driving the renewable energy projects that threaten to bury Doggerland a second time. There is a deeper discomfort embedded in all of this, one that extends beyond the logistics of who gets to dig where. It concerns what we choose to remember. The civilizations that rest underwater were not mythological. They were not apocalyptic. They were ordinary communities of people living on coastlines that no longer exist, raising children, catching fish, building homes, burying their dead. They did not vanish because of hubris or divine punishment. They vanished because the planet's climate shifted, as it had before and as it is doing again, and the water rose. Their disappearance was, for most of them, too slow to be experienced as catastrophe and too fast to be adapted to indefinitely. It was the kind of loss that happens between generations, a grandparent's shoreline becoming a grandchild's open sea. What these submerged settlements preserve in their walls and bones and worked flint is not a warning in the theatrical sense. It is something more precise. It is a physical record of what happens when the boundary between land and ocean moves, a record written not in myth or scripture, but in the sediment itself. The coastline is not a fixed line. It never has been, and the civilizations that treated it as permanent are now resting quietly in the places where the sea decided to stay.